This is part two of linear equations, and it's part two of finding slope as it relates to a rate of change. Now, when I have a slope, usually I'm looking at some sort of constant variation. So kilometers per hour, so I go travel 100 kilometers per hour down the highway, or it's going to cost me $1.40 at the gas station per liter of gas that I want to buy. But what happens if you don't have the slope, but instead you just have 2 points on that line? So I want to try to find the slope in this example of my line where I know I have the points 2 and 3 and 8 and 6. I know that my slope which is also my rate of change, is equal to the rise over the run. So just from a graphical sense, I can just look at it. So how high did I go versus how much did I run? So I went from here to here, so that's 1, 2, 3, and then I went over, or I ran 1, 2, 3, 4, 5, and 6. So my change here, my slope, my rise is going to be 3 over 6, and when I put in lowest common, it's going to be 1 over 2, which is fine. I can figure it out. That's just a graphic way of figuring it out. But there's also an algebraic way, and I have an equation that I can use. So now I have a brand new equation for slope, in which I take the y value for my second coordinate, subtract it from the y value of my first coordinate over the x value of my second coordinate, subtract the x value of my first coordinate. And what is the first coordinate? What's the second coordinate? Well, do it the same way as you would read. It goes left to right. So this right here is my 1. This right here is my second coordinate, 2. And from there, I just plug in the values to this formula. So I have y2, so it's the y value here, and it's going to be 6. Subtract my y value for 1, which is going to be 3. And that's going to be over my x value for 2, 8. Subtract my x value for 1, which is 2, and no big surprise, I get 3 over 6, which is also equal to 1 over 2. Now, this works for any situation, rates of change, any sort of graphical situation, or if I just give you 2 points on some line. So it works for any of these situations. So this is just another method. It's an algebraic method to help us try and figure out slope. And as again, if the line is going from the top left, so I'm going from up here to maybe down here, well, in that case, I'd have a negative slope, and that would bear out when I plug this in.